In this video, I'll show you how to solve the ALEKS problem called Deducing Valence Electron Configuration from Trends in Successive Ionization Energies. This problem is going to give us two clues to help us identify a particular element. The first clue that you want to look at is the general location of the element. Mine is located in period 2. The periods are the horizontal rows on the periodic table, and again, I'm in period 2, which means that my element is one of these guys right here. Second thing that we're going to do is look at the ionization energies. The ionization energies, this is the energy required to remove an electron from the atom or electrons from the atom, and this is basically telling us the number of valence electrons there are in the atom. So I want to give you a reminder. The number of valence electrons increases as we go across the different columns on the periodic table. So these elements all have one valence electron, these have 2, these have 3, 4, etc. You get the idea. One exception is that helium, even though it's in that 8th column, helium only has 2 valence electrons. So when you're looking at your ionization energy data, you're going to see that there is a gradual increase of ionization energies followed at some point by a pretty sharp spike up. And for me, I have a gradual increase through ionization energies 1 through 4, and then it spikes up at number 5. Your data is not necessarily going to look exactly the same as this, so your data could look like this, where you would see a gradual increase for 2, and then it spikes up like that. What you're going to do is count the number of relatively low data points that you have before that big spike. So I have 4 data points before my big spike. That tells me the number of valence electrons in my element. So I have 1, 2, 3, 4 valence electrons, which tells me that I have carbon. Let's just pretend like, what if you had data that looked like this instead? So you're again going to count the number of data points that you have that are relatively low. For this data, there would be 2 data points that are relatively low, which means that this element has 2 valence electrons, which would make it beryllium, Be. ALEKS wants you to just write the atomic symbol, not the full element's name. So for mine, because I have carbon, I'm just writing the symbol C.